Welcome. This is the Whirlpool Galaxy. Mario mentioned that I was not an astronomer. I am not an astronomer. In addition to thanking John for the presentation, I have to thank astronomers for making it possible for me to stand in front of you and talk about searching for extraterrestrials. I have a degree in physics. I have a PhD in psychology with electrical engineering, and I have a Master of Arts in Theoretical Linguistics. I work in the computer science department, but I'm not a computer scientist. I'm actually a cognitive scientist. I try to study how people think. In fact, how anything with a brain thinks, or must think, or must sense the world around it. And hence, my interest in extraterrestrials has a sort of logical path, in my mind at least, to what I do. It's worth saying that I had this wacky idea of using pulsars, about which you'll hear a bit more, a few years ago, and was able to give a talk at a workshop almost exactly 3 years ago in Paris, where I met a famous astronomer called Jean Schneider, who's working on exoplanets. And 3 years later, I have 3 terabytes of data, which I gathered at Arecibo. So I've come a long way, very fast. But let's have a look at how I got there. So we have a galaxy. Let's instead have a look at a night sky and think about how we might look for extraterrestrials. We have a large orb in the sky, which is still moving, I take it.
The sun.
The sun, but it's dark. Well, anyway. Okay, we tend to look for extraterrestrials because we believe the heavens to be inhabited. And we can, this is 1:15 p.m. If we can zip forward a little bit to a night time, it might be handy, because then we can have a look at some of the patterns of the constellations that cultures before us have drawn on the sky or imagined to exist in the sky. Human experience of the universe tends not to include lifelessness. Oh, there's Ryan, right. And we tend to imagine the universe to be inhabited. These are the stick drawings of the constellations. You can see the twins up above you, and now you can see the twins in cartoon outline. We tend to imagine the universe as inhabited. And it might be fanciful to suppose that a reluctance to assume that it was without life gave rise to these fanciful constructs imposed upon the sky. The more prosaic say it's just a navigational aid so that you know where you are and when. I tend to think it's an unwillingness to assume lifelessness. But let's go back to the stars for a minute. If we want to look for intelligence out there, we can jump forward in time and leave the Greeks, quickly get past the problems caused by Aristotle, who assumed that the Earth was the centre of everything and held up conceptual development for a couple of thousand years. I know that's controversial, but why not? And so in the 19th century, later part of the 19th century, when telescopes improved, we could imagine looking at planets and thinking there might be life on them. There was the notion of biology becoming a little bit more universal. People were talking about evolution, about patterns of life in general, and people started looking at Mars, which John can probably helpfully point out there, just over your right ear, where people imagined they saw canals and evidence of life. Around about 100 years ago, when radio was invented, the search for extraterrestrials, in a sense, took a different form. Instead of being a preoccupation of philosophers or cranks, it became a technical challenge. And we could actually imagine listening for extraterrestrials. And it is that preoccupation, listening for extraterrestrials, which is still with us, as we will hear a little bit later. The importance of radio in human culture shouldn't be underestimated. In 1924, the US Army Corps set up radio stations to listen for signals from Mars. And that was because Mars happened to be particularly close in its orbital alignments with the Earth at that time. 1933, a date which will come up a little bit later in the talk, or close to it, mid-1930s. 2 million people in the UK were building radio sets. Radio is very important. That's where the notion of a breadboard circuit comes from. You bought your breadboard and you screwed things down to it. So radio is quite significant. Further forward, after the Second World War, radio telescopes were invented and became the astronomer's tool of choice for looking for extraterrestrials. And we can have a look at a radio telescope. I hope, in a minute. Here we go. Right. These really are sheep, okay? These critters. This is a dead radio telescope. It's the Pulsar Discovery radio telescope at Lord's Bridge, just outside Cambridge. This was originally lots of dipoles and reflector wires and all sorts of stuff. Here is one of the feeds from one of the dipoles. There's a bit of a dipole. It's a wreck. It's long since decommissioned. Technology doesn't really last very well when you stick it out in the field like that. It's important for the discovery of pulsars for a good, straightforward philosophy of science type reason, and it's worth dwelling just a moment or two on that. It was built to study the globularity of the solar wind. The sun spews out stuff which whizzes past the Earth, and that stuff is sort of irregular in density and so on. And it was assumed when they built this radio telescope that distant stars emitting radio waves, and there was a catalogue of these things, different stars at some distances, were constant sources of radio energy. And that if you built a radio telescope like this to look at one of those distant stars, as the globby solar wind whizzed past, it would cause fluctuations in your radio signals, and those fluctuations would tell you something about the globularity of the solar wind. So they built the telescope, turned it on. In fact, I helped build it in 1967. It was built, it was turned on, and they discovered pulsars. The assumption that stars were not fluctuating was false. Okay, the science was good, the measurements were very objective. They spent several months trying to track down radio frequency interference, and eventually they gave up and recognized that they were really observing stars which were pulsing. And it's an object lesson because you think you know what you're going to look for and you can get it wrong. And they got it wrong. So pulsars were discovered with that now dead telescope. Pulsars are a major preoccupation of astronomers, radio astronomers. And another telescope which is used to work on pulsars is the very big telescope at Arecibo. This shows the underneath. This is the reflective surface, which I'll show you in a minute, of the dish at Arecibo. This is a road. It goes down. This is a large block of concrete You probably can't see there's a couple of wires attached to that, and I'll tell you about that in a minute. All of this is vegetation, which is just bursting to get up and push the dish out of the way. Let's have a look down on top of the dish. This is the reflector surface. We were just underneath that. It's made of mesh. It's profiled to within about 3 millimeters. And this houses this bit here houses the receiver technology. Because this is a spherical reflector, or section of a sphere, you've got some extra mirrors in there to cope with the weird geometry. So you've got 2 more mirrors in there. This is big. You could put a Victorian house in there with plenty of roofs there. The whole of this thing is enormous. It weighs 1,000 tons. These wires, they go down to those concrete blocks I mentioned. They hold this thing stable to within about 1/8 of an inch, within 3 millimeters. So the whole thing is rock solid. When you go up there, it's absolutely rock solid. Let's have a look at the next slide. Here's another view of it. Any of you seen that before? Some of you may have seen that. If you, not that you've been there, but you may have seen it in a film. Yeah? It was in James Bond, GoldenEye. That was filmed up there. Okay. It's an awesome place to be. I mean, it's 1,000 tons of technology and it's held up in space to within 1/8 of an inch. It's pretty amazing. Okay, so they use this radio telescope to explore the radio heavens, and indeed I have used it to gather data for an extraterrestrial search. It's been used in other searches as well. It's worth pointing out, and I can mention it at this point before we go and have a look at some more sky, it's worth pointing out that there are probably 3 main techniques for using radio telescopes to search for extraterrestrials. One is to do a general sky survey, where you try and look at all of the sky. And there is, in fact, a little bit on the back here. How many of you have used SETI at home? Any of you use SETI? Some of you use it. Okay, that's where the signals come from. Every time Arecibo is pointing at a real target, there's this little antenna at the back which sweeps the sky and gathers data for the SETI at home enterprise. That's a general sky survey. You can also target stars. I've targeted stars, but in a very specific way. Generally, people target stars believing that there's some particular reason to look at particular stars. We can discuss that in a minute. The third way is to eavesdrop on the sort of radio noise produced by the Earth. And we'll see something of that in a minute. Let's leave Arecibo, and in fact, we're going to go to the Antarctic, and then we're going to leave the Earth behind. This is quite a cool piece of video. So here we are in the Antarctic, and these are the mountains around us, and you can see the sky moving a little bit. And then shortly, we take off into space. That's Antarctica. We'll have a look at that again later. Okay, we're going to leave the Earth far behind. First you find the planets and the Sun moving into view. And then a little bit later you'll find the nearby stars coming into view. Just a few light years from us. mentioned there was eavesdropping as a technique of looking for extraterrestrials. What you just heard was a jumble of radio signals intended sort of to give you the auditory impression of what the radiosphere is all about. The idea is that the Earth has briefly glowed brightly at radio frequencies. You might want to think starting around about the 1930s. I've set the radius of that sphere to be 70 light years, taking us back to 1935. There would have been significant radio emission by then. The radio emission would have peaked around about, I guess, the 60s, height of the Cold War. Think of Voice of America battling with Radio Moscow, battling with Radio Peking and Radio Vatican Radio, sorry, as it was called. These radio stations, shortwave radio stations, were pumping out megawatts of power, tons of energy being broadcast. And television was being broadcast at fairly high intensities in those days. So maybe about 50 light years, a slightly smaller radiosphere, you would find, if you were an extraterrestrial eavesdropping on the Earth, civilization on Earth represented by I Love Lucy and Sergeant Bilko and things of that nature, along with bombastic shortwave radio, if you could understand it, from America and Russia. The notion that the Earth is a radio source because of mankind's activity was popular in the 70s and 80s and 90s, but it's dropped off now because it's recognized that the transmission from the Earth at radio frequencies is nothing like as intense as it was. Radio receivers are much more sensitive, television receivers are much more sensitive. It's expensive to waste power in your aerials, your antennae, sending stuff out into space. You do much better to direct it at your receivers. So you've got satellites beaming signals to Earth, rather than powerful transmitters on Earth beaming stuff out into space and wasting it. So the Earth is by now much dimmer than it was at radio waves. But this sort of shell of radio brightness is moving out from us at the speed of light, getting ever dimmer, of course, as the distance increases. But that's one way in which it's thought you might be able to do a search for extraterrestrials. You might eavesdrop, try to eavesdrop. You might do that in a general sky survey way, or you might do it by picking on particular stars that you think are worth listening to. Notice, listen. The fourth way, the way that I've invented, is based on pulsars. Now, these blue objects in the sky here are pulsars. The published pulsar inventory at about 1300 is already a bit out of date. 1600 or so, I think, is the latest, with private catalogues in Australia. But there are lots of these pulsars. They're mostly focused around the galactic disk, the equator, if you like, which you can see outlined with that dotted line there. And most of the blue dots are indeed in that area, mostly towards the centre of the galaxy. But it's important to note that they're not all on that plane with the disk, the galactic disk. So there are pulsars, in fact, all around us. And that's useful because the technique I proposed is to use them as references, and we'll see that in a minute. But there's actually a much bigger worry for anyone who wants to search for extraterrestrials, and that's simply the size of the problem. It's really enormous. This is just us, as it were, in a sphere 70 light years across. Let's just have a look at the scale of the problem by going to have a look at the galaxy. That's a sphere 1,000 light years across, just there, with the sun in the middle. And here's the galaxy. The sun will briefly flare just to make sure you can see it there. And here we've got more well-known features around us. Various clouds. The small Magellanic Cloud is just coming over the back of your heads and will come down in front of us. We're now moving away from our galaxy at 5,000 light years a second. Right. The galaxy contains, by estimate I suppose, nobody's counted it for sure, 100 billion stars. That's a lot, 100,000 million stars. But that's only a small part of the problem. If we have a look at another photograph, we can see just what the scale of the problem is. This is the Hubble Ultra Deep Field photograph. These are all galaxies except for the 3 or 4 that you can see with little cross shapes on them, which are stars nearby. This is what happens if you put a telescope into space and you put a camera on it, and you open a shutter, and you keep the thing pointing at a particular part of the sky, very small part, quarter of the area of the moon by visual inspection. And you keep the shutter open for 10 days. 100 billion galaxies. Each one contains 100 billion stars. That's a large number by anybody's count. So, if you're going to search for extraterrestrials, you've got a problem. You've got a problem of scale, of magnitude. It's just horrendous. So you need to find some way of reducing the problem to a manageable scale. Don't forget, ETI, if they are interested in contacting us, has to also solve the same problem. Okay? They may also be interested in knowing if there's anyone there. So when we ask, are we alone, we assume that extraterrestrials will be asking that question too. So they face the same problem we face. So let's get back to a slightly more realistic view of things. Let's have a look at a galaxy. This little blob here is sort of to remind you that the sun is not in the middle of the galaxy. This is not our galaxy, this is the local galaxy. Not all of the galaxy is habitable. So you have to think about where in the galaxy you would point your telescope. But there's still 100 billion stars, and even if you look nearby, there's still millions and millions of them. So let's come back down to Arecibo and have a look at the sky. Right, we have just above me a constellation called Scorpio and a star cluster called M62. M62 is quite interesting in my search for reasons that I'll explain in a minute. But it's a cluster of stars and it contains quite a few pulsars. Star clusters are thought to be good places to find pulsars, and indeed I'm making use of 6 pulsars in M62. So what am I actually doing with pulsars? Just remember M62 and 6 pulsars, because that'll go and it won't come back. But let's just have a look at the raw sketch of the idea of how I search for... Oh no, before we do that, John, don't press the button yet. Before we do that, let's just get a scale, a feel of the scale. We can project onto the sky something in the region of a few 100,000 stars. Okay, that's a lot. I think it was 2 million, John said. That's a lot. It's still too many to look at. If you could whittle them down to this sort of number, 2,000, you'd be doing much better. How do you do that? You've got to find habitable stars. Well, the stars obviously are not you would assume planets around stars. So you've got to identify stars, which we call Hab stars, which could support life with planets around them. And there are published catalogues of Hab stars, but they're still very big. The smallest published catalogue is about 17,000. It's still a lot. So you've got to find a way of reducing that number to a manageable search number. And the way to do that is, now we'll have a look at aligning Earth with some pulsars. The blue dot on your right is a pulsar, the green dot in the middle is Earth, and the yellow dot is a Hab star with presumed extraterrestrial in orbit around it. And the scheme, very crudely, is that Hab star pretends to be a mirror. The pulsar's pulses are visible to us, but also to extraterrestrials around the Hab star. And the extraterrestrial transmits pulses back to us at the same pulse rate as the pulsar is producing. There are some minor calculations you have to do to correct for relative motion, but by and large the story is that if you stand with a pulsar behind you and you look at a Hab star in front of you and you see a signal coming from that Hab star which is pulsing at the same rate as the Hab star, as the pulsar behind you, then you know that you're looking at an artifactual signal. You don't know anything about the content of the signal, there's nothing here to do with messages, you don't even know the protocol of the transmission system. All you know is that you're looking at an artifact, and that's crucial. You could actually swap the position of the Earth and the Hab star, and you could look, as it were, just past the Hab star towards a pulsar. And again, if the Hab star was transmitting a pulse like the pulsars, you would pick it up as a separate pulse train, and you would know it was an artifact. Now, M62, containing 6 pulsars, of interest to me, but there are more pulsars, just happens, can we switch back the other way, John, to the green and yellow? M62 contains, over there on the right, contains 6 pulsars of interest, and over here towards me there are 3 Hab stars which happen to line up well enough to a straight line to be considered interesting objects. One is about 130 light years away, one's about 400 light years away, and one's about 700 light years away. I've talked a lot about pulsars and their pulsing. They're dead stars which are neutron stars, very small, spinning, producing energy and beams rather like a lighthouse. And it's the way the lighthouse sweeps past the Earth that gives us this sense of a pulse. The star itself isn't pulsing, it's revolving, spinning very fast, with fantastic precision. Some of them rival atomic clocks in terms of their spin precision. But if we lose that image for a moment, we can hear some pulsars. And John Bank, who provided those soundtracks, have also provided a video, which is quite impressive. that's a representation, I suppose, of fantasy of visiting 47 pulsars. Now, why all this emphasis on pulsars? The alignment is crucial, but the most important thing is to recognise that the extraterrestrial has the same problem we do. This is where the cognitive science comes in. We must assume that the extraterrestrial is trying to solve the same problem that we're trying to solve. And the extraterrestrial must think of a way of beaming signals at likely stars. It will have its own list of HAB stars. It must beam signals at HAB stars in such a way that an extraterrestrial, from its point of view, namely us, will think of the same technique for pointing the telescopes and the transmitters and the receivers. In other words, we've got to understand that we share the same solution to the same problem. Otherwise, we will look in the wrong place, and they will send signals to stars that will never think of looking at them, which is a waste of time as well as energy. So we have to assume that we could find a way, and this pulsar alignment stresses only one possible way. I'm sure somebody in the audience will invent another way. We have to find a way of reaching a shared solution that both we and the extraterrestrials know to be a shared solution to the problem we both know, we both face. That's to assume, of course, that extraterrestrials are interested in finding out if they are alone in the universe. And I just assume that because it is a question that is of interest to us and Earthlings in general, it must be of interest to extraterrestrials. We've talked about the scale of the problem, we've talked about possible solutions. There is the time scale. I mentioned some of these HAB stars that I'm looking at are quite far away, so a conversation would take an infeasible amount of time. There's no point in saying hi and waiting 300 years to get back the answer hi. That's not a good basis for a relationship. So it's better to think of other sorts of messages that we might want to send. I'm not going to talk about messages, that's a whole other topic, and we don't have time. What I think is more interesting is to talk about the problem which is referred to as Fermi's paradox. Enrico Fermi in 1950 had this question he asked, where is everybody? The point being that if you assume that out of the billions of stars around us, even those that are quite close to us, may be inhabited, surely they would have set up, some sort of galactic bus tour company and be tripping tourists around and about in the galaxy, and they would have stumbled across us by now. I'm not sure that that's a very feasible way of thinking about things. If you're going to look at the universe, you have to remember that you are bound by the physics that you know. We believe, we know for sure, that faster than light, superluminal as it's called, faster than light travel is impossible. I'm not sure that a bus tour company is going to get very many customers if they say, by the way, we're going to take you on a tour to Earth, and it's going to take a few thousand years to get there, so you won't get to see it, but some of your remote offspring might get to see it. They're not going to get customers as a tour operator. So it's not clear to me why people would ever travel around in the universe. I think the answer to the question, are we alone, is actually to do with sending messages. So my personal answer to Fermi's question, where are they, is probably at home having lunch, and that really they're in the business of sending radio signals, not travelling around. But even that presupposes one other really difficult problem that we on Earth have to solve. Let's go back and take another look at Antarctica. Okay, probably the most stable civilization we could argue that has existed on Earth for any significant period of time, and I'm talking thousands of years, is probably the Egyptians, although they had a dark patch. We currently are not very good at looking after our planet. Some of you may have seen a Scientific American article some while back suggesting that actually global warming started about 8,000 years ago with significant effect of slash and burn and development of management of crops. More commonly it's cited as being a problem of technology which has been around for perhaps a few hundred years. Either way, that white mass of ice at Antarctica is not going to be with us very long. Water levels could rise, some people project, over 100 meters. So London is then only for underwater tourists, and so on and so forth. And quite soon, by the end of the century, conceivably. So we're not really very good at looking after our planet. Could we really manage a communication effort for communicating with extraterrestrials if the conversational turn takes a few hundred years, maybe 1,000 years, maybe 1,400 years? It requires a tremendous amount of socio-technical commitment to build transmitters and manage them. Recall I showed you the dipole array at Lord's Bridge as a wreck with sheep growing around it. And I showed you the dish at Arecibo with the weeds underneath the metal. Weeds push against metal for years and years and years, and eventually the metal will give way. Arecibo will be rusting away in 50 years' time. It was built in '63 and probably won't last more than another 20 or 30 years, I would imagine. These are all short times. So Arecibo might exist for 60 or 70 years. You've got to build something that exists for hundreds of years if you're going to do work on extraterrestrial communication, serious work. Sure, you can listen, and if you find something, great. Then what are you going to do? You're going to try and transmit back. Then you've got to establish a socio-technical institution which is good for hundreds of years. So on the one hand, you can be really, really pessimistic. Okay? You are privileged to see the ice on Antarctica from space. This will soon be history. Or you could take an optimistic view and say that the effort required to really commit yourself to searching for extraterrestrials and doing something about that as a serious scientific endeavour requires you to have a really, really long-term view. And if you're going to have a really, really long-term view, you've got to have a really good long-term solution to global warming and all the other problems that we face on planet Earth. So, you can be optimistic or pessimistic. Let's just come back to Earth and have a look at a sunrise.
Questions?
Yeah.
Do you know if any intelligent life exists?
We do not know.
In this galaxy?
We do not know if any intelligent life exists. I'm busy searching. I'm actually I believe I'm the only academic, as opposed to amateurs, outside of the US who's doing any serious searching. There are hundreds, even thousands, of amateurs around the world who manage their own radio telescopes in their own backyard. I'm not joking. Sometimes quite big telescopes, 30 foot across maybe, 15 foot across. Lots of people have radio telescopes, and they're continuing to search. So lots and lots of people are searching, but in the academic world, in the scientific world, in terms of big science, like Arecibo, there are very, very few. And nothing's been found. Yeah.
So I must have missed starting with the what.
You were probably asleep.
No, I wasn't. What you're looking at is the assumption that a reasonable way for somebody else's signal would be to re-regulate the pattern of a pulsar which is remote from there. So if you see two signals coming on the same time from different parts of the sky.
From diametrically opposite. That's the crucial thing, diametrically opposite.
Why is it diametrically?
Diametrically opposite is good because it's a nice predictable direction, and it serves to whittle down the number of Hab stars you might look at.
But doesn't that imply that that's people who will be signaling explicitly to us rather than
Precisely.
Oh, I see. Okay.
Precisely, and that's the point, that they must have the same idea that we have as to how to solve the problem. Yeah.
And how towards stars?
How do I define those? I refer you to Maggie Turnbull's article in whatever it is I talk to you afterwards. There is a big list. Yeah, John.
If they're re-radiating the same pattern as a pulsar, how do you know it's not a pulsar?
Because it's at precisely the same frequency but from the opposite direction and only at a particular radio frequency. I nicely glossed over the fact that you've got to choose what radio frequency to look at. There is an assumption in the SETI world that you tune your radio receivers to 1.42 gigahertz, which is the hydrogen line, and that you would expect the extraterrestrial to just pulse away on that particular frequency on the radio dial. Yeah, John.
Would it be fair to say that one of the advantages of what you're saying is that pulsars radiate at a very, very predictable frequency? It's one of the best numbers known. So when you measure a pulsar, a pulsar's frequency, we can tell it to, you know, 10 significant figures. So we're already going to start asking questions if we discover two pulsars in different parts of the sky, which have exactly the same frequency.
You do have to make some assumptions about relative motion of our cells, but provided you do all the corrections and you find that the numbers are the same, then you do have to start asking questions. And so in that sense, you assume that what you're looking at is guaranteed an artifact. And that was the point I made about not knowing the protocol. You don't have to know anything about what they're transmitting, or even how they set up the pattern of transmissions. Although, actually, a cluster is a good thing, because if you've got 6 pulsars as references, all pulsing at different rates, and the ETI chooses all those 6 frequencies to reflect back to us, then you've got 6 parallel channels that you can use for communication. But you know it's an artifact even before you've deciphered the protocol, deciphered the message, worked out the scan rate for the images, or whatever it is. You know it's an artifact. Yeah, Rebecca.
If we were to detect one of these,
Yeah.
could we do the same thing to reply?
We could. That's what I meant about the socio-technical commitment. We could use Arecibo, or we could build a special facility just for that purpose. We'd have to give it a significant budget, because it would have to transmit for a few hundred years.
Or we could say we, you mean
Yes. We'd have to work out what to put into the signal, and then you're into a whole different debate about what is a sensible message content, quotes unquote. Help. Yes. Well, maybe. I mean, that's a different talk. But yes, indeed we could. And in fact, I've argued elsewhere that for us to do good SETI science, we should be almost at the point of pressing the send button, because then we're understanding what it is that they must be doing to send to us. Yeah?
How quickly you get through the data?
How quickly am I getting through the data? Do you want to help? It's horrendous. Absolutely horrendous. 3 terabytes is a lot of data. And we're still working out the best techniques for looking for pulses in the data. There are obviously good, established signal processing techniques which radio astronomers use. And there's a very good book for those techies amongst you by Lorimer and Kramer from Jodrell Bank, which looks at the various techniques that you use. We're developing, actually, I've got 2 colleagues, undergraduates, who are doing their 3rd-year projects currently, developing different techniques, new techniques, particle filters and sorts of great stuff, and finding some strange things in the star data, not SETI, but strange periodicities and odd patterns in the noise, low frequency noise, which we weren't expecting, and all sorts of stuff. But yeah, it's a lot of work. It's a tremendous amount of work. Come and do a PhD. Are you doing them? Oh, right. Yes.
Do you believe that there are intelligent?
Do I believe? Yes, I do. Yes.
Yes, I just wondered how the search for extrasolar
Planets.
was going. That's firstly. And secondly, would you expect your intelligence, extraterrestrial intelligence, to come necessarily from Earth-like planets or would you widen the...
Okay, yes, I think the count of exoplanets is over 100, isn't it? Yeah, 160, gosh, it was about 110 when I last talked to Prof. Schneider in Paris. Anyway, yeah, it's 160 and rising, inevitably.
But they're not Earth-like planets.
They're not Earth-like planets, no. Would I expect it to be sensible to look at other... I think not. I think it's a bit arrogant because I'm not a biologist, but from what I've heard of astrobiologists talking, it makes no sense whatsoever to assume that there's any other basis for life than carbon life forms. If you assume carbon life forms, then you have to assume certain things about the environment which support carbon life forms, to do with the radiative energy of the sun, and so on and so forth. And you very quickly find yourself argued into a corner to say, effectively, you're looking for life forms like us, and following into the point about them thinking the same way as we're thinking. Intelligence is like us.
Yes, I was just wondering, French Moral published a book long ago, didn't he, called The Black Cloud?
Black Cloud, yes.
But that sort of idea you think
as a cognitive scientist, I think that's just good science fiction, but it isn't science. I mean, that I can give reasons as to why I think it's cognitive science rubbish, but it's good. Yes. Yes?
Isn't the 21 centimetre line exactly the worst?
Yes, indeed it is. No, indeed it is. And you're not the first to point that out. Eric Gerard of the observatory in Paris has pointed that out. That extraterrestrials would be astronomers just like we are, and they would want to protect the 21 centimetre line just as we do. And so the last thing they would want to do was to fill it with gigawatts of power.
No, but it's the interference you receive from all around space, which is...
Oh no, because that's interesting, because one of the interesting things about searching for pulses is because you know the pulse rate you're looking for, you can filter out the radio frequency interference because it's not pulsing at that rate. It will smear across your band, yes, of course it will. But if you are using sufficiently cool techniques for picking out periodicities in your signals, then you can, in particular folding technologies, you can actually enhance the signal to noise ratio to get around the radio frequency interference problem. But Yeah, there are problems with the 21 centimetre line. I personally have chosen to direct the Arecibo telescope at the 21 centimetre line, the two hydroxyl lines at 1665 and 1667, and just a broad band in between the two. I think the hydroxyl is better, it's quieter. Yeah, Mary.
No, just a comment, and that I never thought of it from this point of view. To carry on a conversation with extraterrestrials, you need to exist a long time as a civilization. And clearly humanity needs an incentive to think in the long term. So I never thought of SETI being able to possibly provide that incentive. Because if we do contact someone, and it's going to take a few hundred years to carry on this conversation, then maybe that will force people to think in the longer term. So I just thought that was a very fresh point.
Yeah, when I'm feeling romantically inclined, I take exactly that positive view. Most of the time, I don't.
Just a quick question, have you heard of the Long Now Foundation?
No.
It's a growing foundation established to set up projects that will force people to think in the long term, in huge time spans. One project is, someone might know more about this, but I've just read a few things, is to build this clock, this huge, well, I don't know how big it's going to be, but very, very durable clock that will tick once a year and then chime every so often, and an hour will be so many hundred years and so on. Just to get people to think in the longer term than just our lifetime.
I think it's important that we should encourage people to think in the long term. I mean, I have a rail pass. I'm getting on, okay? There are youngsters here who may go on to do astronomy and do interesting things with extraterrestrials. Their children and their children's children will be doing that stuff. Otherwise, there's no point in doing science. I mean, if you don't have that long-term view, it really is pointless. So I think, yeah, we should encourage the long view. Yeah?
Are we just looking for the answer yes? At
Um,
the end of the day, you said that we're not going to live. The planets and the tectonic plates are going to be shifting, so whatever we build is going to go offline. We're going to go into meltdown in whatever areas we are. So are we just looking for that answer? Yes. Because
that we are alone, or the answer no, that we're not alone.
Exactly.
Yes, I tend to agree that actually that in itself is an interesting answer to have. I mean, did I point out? I should have pointed out. There's a quote by Arthur C. Clarke. You know, you can contemplate whether you're alone or not. If you think you are, that's a pretty staggering thing to think. If you think you're not, that is equally a pretty staggering thing to think. And I think if we could have some firmness for one view or the other, some belief that there really isn't another life out there, or there really is another life out there, that in a sense is has as it were, satisfied the appetite for asking the question. I think going there is something else again. Now, Rebecca suggested help as the message. Science fiction writers suggest we, you know, as the Earth melts or does whatever it's going to do under our influence, we should be sending off groups of people into space to colonize other worlds and so on and so forth. You know, we're going to make a mess of another one. Okay? I don't see the point in going there just to make a mess of another one. So I think those are science fiction stories. I'm not, in a sense, that interested in those infinite number of possible ways of going forward. But the answer, are we alone? Yes or no? I think that's an interesting answer, and I want to find it. Yeah, always two there. Yeah.
Your technique with the pulsars presupposes that the intelligent life outside is as intelligent as you are.
Yes.
Now, you've come up with this idea.
Yes.
You're just one of however
6 billion.
6 billion.
Yes.
And over a 17-year period, if you hadn't been around, we wouldn't have thought of it. So
somebody might have thought of it. It's been described to me as unbelievably obvious.
yeah.
But I mean, I take your point. Yes, it's. Somebody else at the conference said, you're looking for intelligences like us. Yes, indeed I am. But then I think there may be other reasons to suppose if we're looking for intelligences, they will have to be closely like us. There are biological reasons to do with creatures having brains and things like that, and the sorts of problems they have to solve in order to crawl around and do things, and evolutionary pressures, that you end up with creatures with brains of sufficient sophistication to cope with technology, and then, wow, you've got radio locked. I think there's a sort of inevitability, but that's an assumption. You had your hand up and then somebody else.
Yes, it's right. I want to make a remark that we can only have the answer yes or no answer.
Yes, we can't have
decisions evidence of absence.
Indeed. Somebody else had one. Yeah.
Do you believe that there is life forms out there?
I do.
Okay, I think we're going to have to start winding down here.
Of course.
We'll be kicked out soon anyway.
Right. Yeah,
but just to remind everyone that we do have the special exhibition coming along on the 8th of April. It's called The Signs of Aliens, and it's from the Science Museum London. We're only the second venue for it in the country before it leaves and goes abroad. So do try to come in and see it. It's here from April to September, and it will look at the whole concept of aliens, from science fiction and aliens in our imaginations, aliens in the way we view other cultures, all the way to the science, to looking for alien SETI and so on. So it's quite a comprehensive look at the topic of aliens.
And I want to thank Mario and Kenny and John, who's just snuck out, for inviting me here to do this, and John for doing the work. He's been programming this. Round in the back there's a rack of computers driving this thing. It's quite amazing. It sure beats PowerPoint, I tell you. It's a great projection system. Thanks very much for having me here.
Great, and thank you.